In this last video, I'm going to speak with you about the coefficient of determination, which is actually a measure of effect size for correlation, and it helps us with interpretation. So the coefficient of determination measures the proportion of variability in one variable that can be determined by the relationship with the other variable. This represents strength. By squaring our R, the proportion of variability, or the change in x and y, is explained. We're going to talk more about this. Let's take a look at some pictures. If we have two variables, the red circle is x and the yellow circle is y, that are completely unrelated, there's no correlation at all, it would be like having two circles that were completely separate from one another. And the correlation here is shown as r equals 0. There's no correlation. If we have an r of 0.50, we start to have some real overlap between the two variables. There's something in common in the middle there that they both share. And so this is the common variance between them. And if we had a perfect correlation, it would be like one circle right on top of the other circle. Now I know you can see the yellow circle underneath this red one, but in actuality, if this were real, you wouldn't see anything. You would just see the red circle completely covering up the yellow circle. A perfect correlation. Perfect overlap. So the overlap represents the amount of variance that can be explained by that relationship between those two variables. And this overlap is called the percent of common variance. So common variance is found by squaring the R and multiplying it by 100. That's so easy, right? So it's the amount of variance, again, I'm repeating myself, in one variable that can be explained by the other. So let's take a look at this. We're going to look at our earlier scenario about diastolic blood pressure readings and overall health scores. We're going to calculate and interpret R squared. Well, first let's look and see what we have. We have an R of negative 0.26. There were 30 participants. P was 0.17 and a two-tailed test. You ready? It was a trick. R was not significant, and so no effect size would be calculated in this particular situation. All right, I won't do that to you again. R equals plus 0.48, N equals 30, P is 0.007. Okay, that's significant, right? Less than 0.05. So from our earlier scenario about blood pressure readings and waist circumference, calculate and interpret the R squared. Pause the computer to do that. Our R squared is 0.23. We get that by taking 0.48, our R, times 0.48, we're squaring our R, to get 0.23. That means 23% of the variance accounted for, or 23% of the variance can be explained by the relationship between x and y. Here's another one. The correlation between marketing costs and release day movie attendance produces a correlation of 0.82. What is the coefficient of determination for these data? Now think about coefficient of determination being R squared. That should help you. And the answer was 0.67. If we take our R and we square it, we got 0.67. Here's another one. The correlation between the number of hours studied and overall grade for an introductory course for nutrition sciences is R equals 0.65. How much variation in the students' grades is not explained by the amount of time they spent studying? So think about how you have to solve this question. Definitely pause the computer to figure it out. And here we go. Our R was 0.65. So we first have to square it to find out what the coefficient of determination is, or what the percent of variance is. So we multiply 0.65 by 0.65 to get 0.42, that coefficient of determination. That's the amount that was explained by the relationship, but the question asked for the amount that wasn't explained by the relationship. To find that, you take a perfect correlation of 1, you minus the amount that was explained, 0.42, which leaves us with 0.58 that was not explained by the relationship. 0.58 times 100, it's 58%, but that wasn't one of your options. 60% was your closest option. All right, let's do this one. Rounded to 2 decimal places, what correlation between 2 variables is necessary to have a coefficient determination of at least 0.80? So let's think about this. I'm going to give you a hint. When you take a decimal and you multiply it by a decimal, your answer is going to be smaller. So that should help you with this answer. The answer was 0.90. And another way that you could have figured this out is by taking the square root of r squared to figure out what the actual r would be. So let's go back and look at that again. We knew that we need to have a coefficient determination of at least 0.80. That is r squared, 0.80. To find r, you just take the square root of 0.80 to get 0.90. Think about that for a little bit. Some of these are a little bit mind-bending, but that's all in good fun. Hope that you enjoyed learning about correlation this week, and I look forward to your questions.